Okay, when we talk about thrust vectoring, of course the first thing that comes to mind, or should come to mind, is the F22 Raptor. The F22 Raptor utilizes thrust vectoring. What happens is they can redirect the thrust in different directions, which is not like something you guys couldn't have like figured out 30, 40 years ago when you first came out with like planes and before you even did the jet aircraft. So probably out of respect put the ASF on there at the end, for Air Superiority Fighter. Okay, the F22 Raptor, they figured out that you put something on the back of basically like little flaps, just like you use for on the wings and on the back tail fins or tail wings, however you call them, that if you move them up and down, you can move the back end of the vehicle up or down, and to, of course, change its front trajectory down or up in relation. And on the side wings of the aircraft, the bigger wings, you can up one side. If you move the flap up on one side, that side will go down. If you move it down, that side will go up, and you can turn the vehicle. Okay, it shouldn't be a far leap to vector the thrust in different, different directions. Here's the thing. Well, you can retrofit the fighters that they probably have. If you took enough time to figure it out, and some inexpensive and just really quick way, they could retrofit the F-15s, F-16s, 18s, whatever they are now that were right before the F-22 Raptor. You can retrofit just about any jet aircraft, probably. It would be limited, but you'd have some kind of type of vectoring capability you could retrofit those to do. Here's the thing. Thrust vectoring is simply just changing the direction. But another thing they've done on the F-22 Raptor is there's two possible ways to say it. Either planing the thrust or compressing it. Planing or compressing the thrust. Here's the deal. Before the F-22 Raptor, here's the back end of the vehicle where the thrust comes out of. Sound effects and everything. Thrust comes shooting out in a big circular thrust pattern, and when it shoots out in a circular thrust pattern, it's dispersing in all directions the farther the thrust goes out. It's dispersing as it moves out. And how it moves forward is the thrust is actually pushing against its own thrust. The thing is, planing or compressing is basically taking off those edges right there. Taking off those edges. Because what happens is, if you can plane it, or in the Raptor's case, it looks more like this. It's how the thrust looks like when it's coming out. What they've done is, the parts on the end here where there would be that extra little circle, let me use my pointer here. Think of this as like a rectangle within a circle. You've got these outer portions of the circle that have been cut off. It's that much less dispersion. A planed or compressed, a flattened out thrust vector has less of a dispersion pattern because you don't have this extra part that would be circular. It's not dispersing in all directions. It's been flattened out, so it's shooting more straight out. A plane or a rectangular type of it's able to shoot the thrust out farther before it disperses. That's what it amounts to. That's how they're able to supercruise. Of course, they probably don't want you all to know that. They probably don't want other countries to know that's what's going on. But that's what happens when you compress or you get rid of this little area that would be right here in the circular part all around it, on the outside of those flat sides there, that would disperse it in all directions. So basically a circular thrust pattern is going to be more efficient at dispersing the thrust as soon as it comes out, meaning less thrust forward. Okay? So with a circular pattern, you have more opportunity for it to disperse in all directions. Here, it's been in a rectangular type pattern, as in the case with the Raptor. They're actually forcing the points at which the circle would be above that. They're compressing it down and making it go up farther out and straighter. So that's pretty much it for the thrust vectoring. What else did I want to say on that? Well, I think that's pretty much it. Thank you.